Law of cosines takes a little bit more work to prove. I'm not going to prove it here, but it's another situation where we have a triangle that isn't a right triangle. We have three sides involved and just one angle. The relationship here is c squared equals a squared plus b squared. So this is the Pythagorean theorem, but it's not a right triangle. There is a little adjustment here. 2ab cosine of theta. Okay, so for example, let's say we had a triangle that had 20 on one side, 10 on the other, and we had 60 degrees right here. We want to figure out this right here. So where does this come about? Well, there's a lot of navigation problems you see in textbooks where one plane traveled 10 miles this way, another plane traveled 20 miles this way, and they are going at an angle 60 degrees from each other. So the question is then, what is the distance between them in the end? So that sort of thing. Alright, well, we're going to let this be c, and this is our theta. C and theta are always going to be across from each other, and a and b are going to be sandwiching the angle for the law of cosine. So if we plug in what we have x squared equals, a in this case would be 10, and b would be 20, and they're both squared. And by the way, they can be interchangeable. A and b do not matter, but the c is the one that has to be across from the angle. That's critical. So this will be 2 times 10 times 20 cosine of the angle. Alright, now most mistakes aren't in actually the setup, it's working through it. Work that out, and then work this out. There are chunks that you need to work out individually. So 10 squared plus 20 squared is 500 minus, and then 2 times 10 times 20 is 400 cosine of 60. I'm just following order of operations here. We got to multiply before we add. The number one mistake that happens here is that we do 500 minus 400 and get 100. But 400 has to be multiplied by cosine of 60 first. And so be careful. Cosine of 60 is 1/2. So if this right here is 1/2, then this is going to be 500 minus 400 times 1/2. So if you work this out, 400 halved is 200. X squared is going to be 300. And the other thing that happens quite often is people forget to square root, because this is x squared. So square rooting, we get an answer of 17.321. That is the opposite side of our triangle. The other thing you're going to see is finding an angle using law of cosine. Now I know that I have to do this with law of cosine because I have 3 sides involved and I'm trying to find one angle. Law of sines does not work here because with law of sines you always have to have at least one of the angles, and here we don't. So if we're trying to find c, I'm going to put a theta there. That means that 7 is our side c, 9 can be our side b, and then 12 can be our side a. Just keep in mind that although these letters match up with what we have, they won't always match up if you see them in the book. So just rewrite the lettering. It doesn't matter as long as c is opposite from theta. Let's plug it in. 7 squared equals a squared is 144, b squared is 9 squared, which is 81, minus okay. Now this is where a lot of issues happen, again, because of order of operations. So I'm actually going to rewrite this 7 squared as 49. Now we're going to subtract 144 and 81 from both sides. When I do 49 minus those two things, I'm getting negative 176 equals, and this right here is left over. Okay, now this right here is equal to negative 216. So I have to divide that on both sides. I'm going to get a 176 all over 216 equals the cosine of theta by dividing by negative 216 on both sides. And the negatives will cancel, so it's positive. Now to get my angle, I'm going to have to do the cosine inverse of 176 over 216. crunching that in your calculator, you should get 35.4 degrees. So, the thing to keep track of, just make sure that you have your C and your theta across from each other, and then plugging in anything else, it should be okay.